Now that we started with polynomials, we are going to look at multiplying them today. I think the only really way to get through this is just to get right after it. I think seeing a lot of examples is helpful, and there's no really any verbiage or vocab we need to learn for today. But for example, if we have this monomial times a binomial, well, we're going to have to distribute. So you had to use your rules of exponents, so this is why this is always taught after learning the rules of exponents. 2x times 5x should be 10x squared, and 2x times negative 6 is negative 12x. Just like negative 4y times 3y minus 8 would be negative 12y squared, and then negative times a negative is plus 32y. You can see examples of a monomial times a trinomial. Just three different terms. Same thing, we're going to multiply each one and then use our rules of exponents to make sure we get the exponents right. So 4 times 3 is 12. X times x squared is x cubed minus 21x squared plus 18x. Sometimes you're going to see the lead coefficient is going to be negative. So you just got to be careful about distributing that negative to every term that's in the polynomial, in this case a trinomial. So negative 2x squared times x squared is negative 2x to the fourth minus 12x cubed plus, right, negative times a negative, 10x squared. Sometimes you will see multiple variables, so you could have, say, 2xy times 3x squared minus 4x plus 5y minus 6y squared, for example. Same deal. Coefficient times coefficient, then we'll worry about the exponent. So 2 times 3 is 6, and then xy times x squared would be x cubed, and the y comes along for the ride. Negative 8 x squared y plus 10 x, now we got y squared, and then minus 12 x y, say it with me, cubed. Sometimes you'll see multiple acts in the same expression. So in this case we'd have 12x minus 10x squared plus 12x squared minus 18x, and then we've got to combine like terms, which looks like I've got negative 10 and positive 12x squared, so 2x squared, and 12x minus 18x is minus 6x. And sometimes they even get uglier. Sometimes you'll see ones that have so much going on they have to have brackets, because inside the brackets you have parentheses. So let's take a look at one like this. We're going to have to start the deepest part of the bracket, which is the parentheses. So that negative 5 has to be distributed to both terms in there. So that's negative 15 and positive 5x, right? The negative 5 and negative x make positive 5x. Let's write the rest of our expression. We have like terms we can combine inside. That becomes 7x minus 15. We've got some distribution. 28x squared minus 60x minus 6x squared plus 5x, and then we're going to combine like terms. So 28 minus 6 is 22x squared, and negative 60 and positive 5 is negative 55x. And just like we did with the previous examples of polynomials, we're going to have equations when we deal with multiplication as well as addition. So for example here, we've got two sets of distribution on the left-hand side of this equation. This becomes 4y minus 28 minus 2y plus 6y squared equals 6y squared. Notice you've got a 6y squared on both sides of the equation, so they are going to cancel, leaving us with 4y minus 28 minus 2y equals 0. We can combine like terms here, get our constant to the other side of the equation, and divide by the coefficient to get a final answer of 14. And let me do one last one that involves some fractions. I know everybody's afraid of fractions. And this will be the last one for this lesson. So 3/2 times 4x. Well, that's the 2 cancels into the 4 twice. 2 times 3 is 6, so that's going to be a 6x. 3/2 of -6 is -9. And this becomes a minus 3x and then plus x squared when I distribute this negative x to both terms. And that's going to equal 1/3 of 3x. 1/3 of 3 is 1, and x times x is x squared. And then 1/3 of 6 is 2, so that's going to be 2x. Again, like the previous problem, the x squared terms on each side of the equation cancel. So I've got 6x minus 9 minus 3x is equal to 2x. Combining like terms on the same side of the equation, bringing all my variables to one side, and finally getting the constant to the other side of the equation. You're welcome.